This section is all about measurement and base units. So you're making a map and you're trying to mark stuff on it. You see a clock in the distance and you walk towards it from your position at the centre of the map, the origin. The clock is 52 paces away. Your friend walks towards it from their position, which is 20 paces east of the origin. The clock is 48 paces from them. Where do you put your clock on the map? Well, again, we don't have quite enough information. What direction did you both walk in? Let's look at this a slightly different way. You walked 52 paces from the origin. Assuming that you walked in a straight line, you could end up anywhere on a circle with its centre at the origin and a radius of 52 paces. Your friend walked 48 paces from their starting point, 20 paces east of the origin, and so could be anywhere on a circle with centre 20 paces east of the origin and a radius of 48 paces. We know that you meet at the clock, so you must be in the same point, the point where the circles cross. But there are two possible choices. So to decide which is correct, we need to know whether your friend was on your right or your left as you walked towards the clock. Again, we've emphasised the need for both magnitude and direction when marking things on maps. However, let's now discuss in more detail how we can be sure where we are. Let's think about whether we've got an accurate map or not. Let's also think about why it matters whether or not our map is accurate. So what do we need maps for? To know where we are in relation to other things, to know how to get to things, what direction to travel in, how far to go, how long it will take us, to be able to plan, to decide where to put things like buildings or roads, for example. To be able to communicate with other people. Other people should be able to use our map for the same things that we can. The map should be universal. Is the map we've been making universal? Or put another way, are my paces the same length as your paces? And are your paces the same length as your friend's paces? No. We need a universal way to measure distance. In fact, we need a universal way to measure everything. Otherwise, different people will do the same thing differently and get different results. For example, their paces will be too short and they won't find the clock with your map. Mechanics is based on universal physical laws. The results of experiments to demonstrate them should be the same whoever does the experiment. But we can only use the results if we use the same measuring system. Otherwise, we end up with different numbers or end up somewhere else with the same map. Our system for measuring physical properties is called the SI-based system, and everything is measured relative to that. In this system, we measure length in metres instead of paces because the metre is the same whoever is measuring it. A metre is the distance light in a vacuum travels in approximately 1/300 millionth of a second, so it depends on what we define a second to be. A second is the time it takes for approximately 9.2 billion oscillations of a cesium atom. Whilst in practical, these definitions are universal because they are based in nature. Interestingly, another base unit, the kilogram, is defined as the mass of the International Prototype Kilogram. A cylinder of platinum, which was commissioned in 1875 and is kept in a vault in Paris. All other kilograms are measured with respect to it, but it is expected that this definition will change soon to be one that is based in nature as well. Having a universal system of measurement means we all get the same results when doing things in the physical world, like reading maps.